So last week Blender 4.0 came out and I was like, let's do a tutorial about the new repeat zone. So what we're going to create is lightning like this. Really cool, with branches and with level of detail and noise. And we're going to do it all with the repeat zone. So let's jump right into it to start mastering the repeat zone. To get started with this lighting generator, we're going to delete everything first and we're going to press Shift A and we're going to add in a simple Bezier curve. In this Bezier curve, we can go into edit mode for that. So if we go into edit mode, then we can basically delete everything. What we want to do is, let's press numpad 1 to go into side view, and we want to click on this draw tool so that we can draw a curve anywhere where we like. And this is pretty handy because then later you will be able to draw your lighting everywhere we like. Let's draw a curve kinda like this. That's fine. Like lightning striking on the ground. From here, let's go out of edit mode, back into object mode, and let's jump right into geometry nodes. And in geometry nodes, let's click on the curve and let's click on new to create a new geometry nodes for this curve. And we're going to create this lightning generator in 2 steps, kind of. We're first going to make a system that will make the curve look more like lighting. So we're going to add in noise. But the good thing is, since we have the repeat zone now, we will be able to determine what is the level of detail. So manually we can set an amount of detail for this curve. It will be really cool. The second system that we're going to create is to create branches. And with the repeat zone, you're going to be able to decide how many branches is my lighting going to have. So you will have a lot of creative freedom with this system. It's going to be really cool. So let's first create the noise system. And the noise system, we're first going to create that without the repeat zone and then with the repeat zone so that you can really see why the repeat zone is such a benefit to work with. So what we're going to start off with first is press Shift A and let's search for a set position node. And let's plug that in right over here. And the set position, the offset of the set position, we're going to make that a noise texture. And for the noise texture, you can connect the color with the offset. Then you see it works. It kind of works. If you change the scaling, you see it gets noisy, but it also gets shifted like this, like diagonally. To center this back to its original position, but to keep the noise, we want to do a vector math node, which we set on subtract. And we want on each axis, we want to subtract 0.5. So that you will see that it's now back on its original position. But when I change the scaling, you will see, we don't really have enough points on this curve to create a good amount of detail. So let's create more points on this curve so that we can crack up the amount of detail. And we're going to do this with a resample curve node. And we're already getting this. Right now, this resample curve node has a count of 10. Which means first the curve had 1, 2, 3, 4 points. But right now the whole curve is divided into 10 points, which we can now give better noise like this. However, I don't want to just make it a count of 10. No, I want to make the resample curve node dependent on the length of the curve. What I basically want to say is don't just put 10 points over here. No, I want to say, okay, every 1 meter of curve, there should be a point. And you can do this by changing the count to length. And now if you make the length, for example, 0.25, then every 0.25 meters, there will be a point on the curve. And this is very handy later when we're going to make the curve more detailed. I also want to have control over the strength of the noise. So what we're going to do is press Shift A and add in a vector math node again and set this from add to scale. But for now, I'm going to keep it on 1, but you can see you can change the scaling and you can change the strength of the noise. So now we have this little system and we have 1 level of detail already. And this first level of detail, you can see that's more like big chunks of noise on it, which is really good, like real lighting. But now I want to take this shape and give it another level of detail. And we're going to do this by disconnecting this one, making a little bit more space. Take this whole thing, Shift D to duplicate it to here, connect the set position with the new resample curve and this one like this. Then you see not really that much happened. That's because we want to change some of the parameters over here because these are now the same as this one. But there are 3 parameters that we want to change within this one. First off, the resample curve node, the length of it, we want to divide that by 2. So we want to say this one, let's divide by 2 so that we have double the amount of points on our curve. Then also in the noise texture, the scaling of the noise, we want to multiply that by 10. so that we have even more noise to work with. But of course, the scaling part, the strength of this second noise should be lower as well. So the scaling over here, I'm going to divide that by 2. And then you will see the difference if I take all of this and I press M to mute it, and you will see the difference. We're basically adding in another level of detail. Let's do this again. So let's disconnect this one, take this, Shift D to duplicate it, connect it again, like this. And then we're going to basically do the same thing. So in the resample curve, we're going to divide the length by 2. In the noise texture, we're going to multiply the scale by 2. And in the scaling node, we're going to divide the scale by 2. And now we're adding in another level of detail. Let's do this one more time. So let's disconnect this like that. Take this one, Shift D to duplicate it to here, connect it like this, connect it like that. And let's do the same thing again. So let's take this one, divide it by 2. Let's take the scale of the noise texture, multiply it by 2. And let's take the scaling of the scaling node and divide that by 2. So that we have even more detail, as you see. I think you're getting the point. But as you see, now we're basically duplicating the same process over and over and over again. And you don't really want to do this because it takes too much time and you don't really have optimization, so to say. And that's where the repeat zone comes into play. So if we disconnect this part and we disconnect this part, we can move all of this away like so, and then take the group input and move it a bit closer again. Then you can also connect it like this. Because let's do all of this just with the repeat zone. Let's press Shift A and add in a repeat zone. And then let's disconnect this one and disconnect this one. And let's put the repeat input over here and the repeat output right over there. Let's disconnect it like this. Let's connect the group input like this, and the geometry just needs to go into the resample curve. The set position goes in the end of the repeat output, and then this one goes into there. If we now set the iterations of the repeat output higher, yeah, nothing will really change. The only thing that will change is that you're getting a different randomization of noise, but we're not really getting a new higher level of noise. That's because these values all stay the same throughout the iterations. If you want to change these values over the iterations, you need to get these values as attributes in the repeat input. So if you click on the repeat input and press N to make this pop-up open, and then under node, you can, in the repeat over here, you can click on plus to add in a new attribute. And this new attribute, you can, for example, call that length. But of course, this should not be a geometry. No, this should be a float. And you see, okay, the length now starts at 0, 0, 0. Yeah, that's not really what you wanted. We want to make it start at 0.25. So let's make this 0.25. And then you can connect it like this. However, now it will still not really change over the iterations. That's because we're still not telling Blender that the length should be divided by 2 for each iteration. So let's do that. So let's add in a math node, put that over here, set this on divide, and then we can divide the length by 2 each iteration. And to do it each iteration, you have to connect this one with the end length. And now if you put the iterations up, you will already see a different result. Like, you will be able to see more detail, right? But of course, to get the same result as before, we also have to do that for the scaling of the noise texture and the scaling of the scale node. So let's click on the repeat input and also add in those two attributes by clicking over here, click plus, plus, and let's make this one the noise scale. And let's make this one the vector math scale. The noise scale should have an initial scaling of 5 and the vector math scale should have an initial scaling of 1. Let's connect the noise scale with the noise scale like this and the vector math scale with the scaling of the vector math like that. But of course, we also have to update these over time. So let's take this divide node and you can basically just press Shift D to duplicate it and Shift D to duplicate it again. This one is going to be for the noise scale. So this one should not be on divide, but this one should be on multiply. So let's set it on multiply and then we can connect the noise scale like this and the vector math scale like that. And let's also connect them, of course, over here so that they will loop over the iterations. And now you will see, if you set the iterations different, you will get a higher resolution of noise. And you can get this very far. So now we're having 8 iterations and you see we can still add in detail. Of course, I don't recommend you to go that far because I think your computer is not going to like that. But after some experimentation, I found out that a level of 4 is already enough. Maybe you can do 5 if you like, but 4 or 5 is enough. And a quick tip, if you want to have like a different randomization of the noise, you can set the noise texture on 4D, and then with this W value, you can change the noise so that you're getting a different lightning effect. Okay, cool. So step 1 is done. We created the system to get a very noisy looking curve that looks a lot like lighting. Now the second step of this tutorial is going to be to create the branches. And those branches are basically going to be instances on these curves. And then the other branches are going to be instances on those curves and on those curves and on those curves. And that way we're going to get a lot of branches. So let's start off by adding in an instance on points node right over there. And as the instance, we want to do a curve line node and connect that as the instance. Then you see we're getting this. Now we get a curve line on every single point of our lightning. And that's not really what we want. So we want to randomly decide which point on our original curve is going to get a branch. And we can do this with the selection socket over here. So if you add in a random value node, which you set from float to Boolean, then you can put the value into the selection. And if you set this probability very low, then you will see just a couple of them are getting branches. I will set this probability even lower to like 0.005. Maybe you want to change the seed value to get more branches for now, for the example. So like this one, for example, that's good. It would be handy for us if we can see these branches with the original curve. So if we for now add in a join geometry, we can put that over here and then connect the repeat zone with that as well, so that we can see the original curve. Okay, a couple of things that I want. I want that these lines are not pointing upwards. I basically want them to point into the direction that the original curve is pointing at, right? So let's do that by changing the rotation over here. We want to make the rotation of these curves dependent on the tangent of the original curve. So let's do Shift A curve tangent node and connect that with the rotation. Then you see, yeah, that doesn't really work yet. That's because we also have to do an align Euler to vector node and connect it to the vector. And let's also set it on Z. Then you see it already starts working pretty well. Okay, and now to get branches, we basically want to put this whole thing into one repeat zone. So let's remove the join geometry over here and let's press Shift A to do another repeat zone. Let's disconnect the repeat zone like this. And then let's make some space like this, disconnect this one, put the repeat input right over there and the repeat output right over there. Then you can connect the group input like this and this one like that. And we can connect the instance on points with the repeat output like this and then connect it like that. And then we see this. Now, if we put the iterations up of this one, you see nothing really happens. Nothing really happens because we have to realize these instances. Otherwise, we cannot put the noise over it and we can also not instance a new point on it. So let's do Shift A and add in a realize instances node right over there. And then if we do the iterations, then you will see we will be able to make it branch, 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 branch. However, we're not really seeing the rest, right? So if every time we do an iteration, the other iteration before that gets deleted. I don't really want this. So in order to keep the original one, we want each iteration to be joined with the previous iterations. So in this first repeat input, we want to create a new attribute socket, a new geometry socket. And this one we're going to name joined branches, something like that. And then if we do a join geometry, and after each time a new curve gets the noise repeat zone, I want to join that with the join branches input, like this. And then if you connect this one with the join branches, now you will see if you put the join branches like this, then you will see that the branches are not getting deleted and you're getting branch, 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 just like this. I will set the iterations on 2 for now, because there's one thing that we need to fix for the noise. Because now you will see if we put branches, you see that the branches start over here or they start over here and they are not connected with the original curve anymore. That's because the noise texture over here does it for the whole curve and it shifts it no matter what. To fix this, we want to make it that the noise is not happening at the beginning of each curve. So in the repeat zone in which we create the noise, I want to do another scaling node by pressing Shift D like this. But this scaling, we're going to control that with a spline parameter node. Because this spline parameter node consists the information that over here it is 0, over here it is 1, and everything in between is a grayscale. Or it's reversed, I'm not really sure yet. So if we now connect the vector with the scaling, then you will see it's always connected with each other. However, you see that the noise is not really looking good over here yet. To make this spline parameter only affect like the beginning of each curve, we can add in a color ramp. And in the color ramp, we can put the white all the way to the left. So that now it's only doing it in the beginning. And you see that the branches are always connected with the original curve that it branched from. So that's good. And it also works for the iterations, of course. To get a little bit more overview in your nodes, you can make a joint over here in the joint geometry by holding down Shift and right click. Make a joint, and then you can move this over here, move this one over there, and then maybe make a joint over here as well, so that you keep your overview in what is happening in all of this. Okay, if I now make more iterations of branches, you see that those branches always stay the same length. But I kind of want that each new lightning branch becomes smaller and smaller and smaller with each new branch. And to do this, we can make the Z end of this curve line dependent on the maximum length of the previous iteration of curves. And to get the length of each curve from the previous iteration, we want to get a spline length node. I will set the iterations on 3, but right now this spline length node, it contains the total length of all the curves together, and that's not what we want. We want to get the maximum length of each curve. So for example, if this is the longest branch of this iteration, we want to get that length and not the length of all the curves combined. And to get this, you can do an attribute statistic node, and you connect the length with the attribute. And the geometry is going to be the curve before it gets affected by the noise. So if you connect this one right over there, and let's make a little bit more overview by creating joints again like this. So like that, and then like so. And now to make the maximum value of this, the z-axis over here, we can do a combine XYZ node, connect that like this, and connect the maximum with the Z. And now to make that with each iteration, the branch becomes twice as small as the previous iteration, you can do a math node, which you set on divide, and you do divide by 2. And then you will see if I set the iterations higher, the branches will become smaller, which is good. You also see that the branches are at some point are getting kind of all over the place like this, and they are not really following the tangent of that curve anymore. That's because it's so noisy that sometimes the tangent goes all the way over there, for example. If you want to have more control over that the branches are more like going into the right direction, you can take this curve tangent and blur that attribute out with a blur attribute node. Set this from float to vector, and then you can connect it like this. And then if you set the iterations to like 9 or something, you will see that it goes a little bit less all over the place and more controlled. Okay, cool. We're now basically done with creating like the branches system. I think the only thing that we should do now is giving this lightning actually thickness so that we can actually see it, right? So let's give it thickness by going over here and do a curve to mesh node. And then as the profile curve, we want to do a curve circle. You connect it like this, then you will see it goes boom all over the place. First of all, to give our computer a little bit more love, we can make the resolution over here 6. Right now these branches are way too thick, of course, so let's make them a little bit thinner. But let's not do that with the radius of the curve circle. No, let's do that over here with a set curve radius node, like this. Then you will see that it only happened for the branches and not for the original curve. That's because we also have to set this set curve radius all the way in the beginning, like this. And then you will see it also happened for the beginning curve. Okay, this already looks pretty cool. However, what I want to do is that the branches become thinner at the end. So now it's all like thick, 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 thick. But I want this to be like thicker over here. And all the way in the end, it should be perfectly thin. And we can do this by making the radius like dependent on a spline parameter node. So let's do a spline parameter node. connect vector with the radius like this, and then you see it becomes way too thick again. That's because it now goes from 1 to 0, but I want this to go from 0 to a small number over here. So let's do a map range node, so that we can say, okay, right now it goes from 0 to 1, but we want this to go from a low number to 0, so that you will see, okay, over here it's now thinner, and here it's perfectly thin. Let's maybe set this a little bit higher to like 0.015. Yeah, that's better. However, this is now not happening for the branches yet. So for the branches, let's do the same thing. Let's go to the curve radius and let's first make some space over here, just like that. Yes. And let's do a spline parameter node, connect that like this. And let's also add in a map range node. And this map range node, let's make it go from a small number to 0. But then we have a problem, because you see over here, yeah, it starts just as thick as it is over here, but I don't want this. This curve, for example, should have a starting thickness the same as this. So this thickness should be the same as this thickness, and from there it should go smaller. So basically we want to find for this curve the thickness of the closest point on the original curve. And to find the closest point, we can do a sample index node, but also a sample nearest node. As both geometries, we want to put the output of the repeat zone. So like this and like that. And then this index, we connect that like this. However, this is not going to work because this sample nearest is not going to work with curves. This needs to be a mesh. So we have to do curve to mesh before the sample nearest, otherwise it's not going to work. And the thing that we want to capture, so to say, is the radius of each point. So connect this one like this. And now if you put the sample index into the set curve radius, then you will see they always start like that. However, they always stay in that thickness. So it's not becoming smaller yet. Very easy to fix this actually. We want to fix this by taking this spline parameter and the map range node and multiplying it with the sample index. So if we do a math node, set this from add to multiply and multiply these two things together, then you'll see they're very small. That's because this map range node should not be 2 min, this should not be like this, it should be 1. And then we have perfectly shrinking branches. And it works for new branches as well. So if we set the iterations higher, you will see it keeps working forever. Cool, now we have this. We have our lighting, that's pretty cool. There are two things that I still want to do. The material, of course, because it needs to emit light. Plus, I want to create the effect that it can like appear like this. So let's first create the material very quickly. Let's do a set material right over here. And let's split our screen in half, change this to the shader editor. Let's also go into the material preview mode over here. Create a new material by clicking on new, and let's name this like lightning. Let's delete the principal BSDF, we don't really need it. And let's do an emission node, connect that like this. Of course, we're not seeing anything happening because in the set material, you have to set the lighting material and then it works. Let's make the color like blue-ish, something like this. And let's also turn on bloom actually so that we can see the glow around it. So let's go over here into the render properties and turn on bloom. We're not seeing any bloom yet because the strength is way too low. So let's set this higher so that we're having some bloom. Let's set the strength on 50, for example. Then you see we're getting really cool lightning already. To make the effect that the lightning like strikes down on something, I want to use the delete geometry node. So if you do a delete geometry, I basically want to delete this part, 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 but then in reversed. So if we put delete geometry like this, and we do a spline parameter like this, and we connect it with the selection, then you see we only have the outer parts. If we now do a math node and we set this from add to greater than, now you will see you will be able, with this threshold value, you will be able to make it appear. But not in a good way, of course, because like these are like the branches are appearing out of thin air. And that's not really what we want. We want, for example, that this one appears when this one is actually right over there. So this one should appear now. To create this effect, we're kind of going to do the same thing as we did with the thickness. So I'm going to make some space over there and also over there. Yes, and I'm going to create an attribute for this, a delete attribute or a trim attribute, whatever you like to call it. And this trim attribute, we're first going to create it for the original curve. So let's make some space over here and let's do a store named attribute. And this attribute is going to be a trim attribute. And what I want this trim attribute to be is very easily a spline parameter that has a vector like this. Now, if you, for example, do a named attribute node and you make this the trim attribute, if you now do Ctrl-Shift click on it and Ctrl-Shift click on this one, then you will see the trim attribute is basically a gradient that goes from there to there. This is good because that's actually what we want. So now basically what we want to do is find for each branch the closest trim value of the original curve. So let's go between the realize instances and the set curve radius. And let's do a store named attribute again, because we want to create the trim attribute for the branches as well. And to make our life a little bit easier, we can basically take the curve to mesh, the sample nearest and the sample index that we had before, Shift D it to here, connect it again in the right way like so. And the value that we want to capture is the trim value from the original curve. So if we do a named attribute and as the name we do trim, then we can put the attribute right over there. And this is going to be the new trim value for these instances. So put it right over there. And now to make this actually work, we're going back to the delete geometry and we don't need the spline parameter anymore. We're going to replace this with a named attribute, which we're going to put on trim. And this one we're going to put in the greater than. And now you will see, voila, you will be able to animate a lightning strike, which is really cool. Looks especially cool with the materials like this. So then we have our lightning generator completely created with geometry nodes with the new repeat zone. So in the upcoming weeks, I'm going to create even more stuff with the repeat zone and maybe also in combination with the simulation nodes to create some really cool tutorials for you. And if you like that, you can give this video a thumbs up, comment down below if you have any questions. And if you want to support the channel and you don't want to miss out on any future videos, I recommend subscribing. And with that being said, I see you in the next one.